Okay. All right, so the next thing we need to take a look at over here active standby, active active. That's a high availability part of it. So what is that? That allows you the ability to bring in redundancy into your network. We'll be taking a look at two different flavors of high availability or redundancy, whatever you want to call it. Let me save this though, because I haven't saved the file today at all. Day 3. And what do we do today? Transparent firewall, security context, and failover. That's what we'll do today. All right, so the next thing we're going to take a look at over here is failover. What does failover bring to the table? It allows you the ability to have redundancy at the box level. So in case you have a connection to the internet, let's say I did not have the second box over here. This is your ASA, your inside network, the outside network. If you want to go from in to out, there's a single point of failure. So rather than doing that, I can get two ASAs, have them talk to each other, so that if something happens to this box, you can forward from there. The two devices share an active address, which is assigned to the role, active, and another address, standby, which is the backup device. Okay? So whoever is the active takes on that active address. For the clients, the default gateway is going to be the active address. Everybody good with that? To set it up, you need to have the two devices connected to each other over a link. This could be through a switch or could be directly connected to each other. They'll share an IP. This link that connects the two firewalls to each other is called the failover LAN interface. It is used for two things. Number one, config replication. So the configuration is only done on the active box, replicated to the standby. And the second thing it's used for is a keep alive. Heartbeat. Good. The problem with this is, although you have two boxes, the other one is a hot spare. What do I mean by hot spare? It's there, but you're not forwarding any traffic with it. One active, one standby. Both cannot be forwarding at the same time. So this is more like your insurance policy. Understood? So how do I set this up? Before I set this up, I want you guys to be aware of a couple of terms over here. Number one, the term active, standby. Actually, let me just write in your notes. Terminology. terminology. Okay, first thing is active, the forwarding box. Standby, as the name suggests, the hot spare. The next thing I want you guys to understand is the terminology called primary. Primary is a priority / name. The forwarding is not necessarily done on the primary. The other one is secondary. Again, a priority and a name. Understood? Let me give you an example of that. Let's say initially I have two firewalls, ASA1 and ASA2. I want this ASA1 to be the forwarding device. So in an election, I want it to win. So I'll set the priority, the unit as a primary unit. That's like a priority. This I'll set up as a secondary unit. You can only have two. Failover is a pair. You cannot have more than two. So based on that, when the election takes place, who wins the election? The primary wins it. He becomes the active box. He becomes the standby box. Everybody good with this so far? Let's say this one conks off. Based on the heartbeat, he finds out. He changes his role to what? Active, and takes on the IP address assigned to the active interface. The active IP is now with the secondary box, but his priority remains secondary. This guy comes back up. He's still the primary, but when he sees that there is a existing active box, there is no preemption in this, he becomes the standby box. His role is still what? Sorry, his priority is still what? Primary. So he's a primary standby. He is the secondary active. So I want you guys to understand there is a difference between active versus primary secondary. Active is the forwarding box. It could either be done on primary or on secondary. Understood? Good so far? The other thing I want you guys to understand before we start this is stateful or stateless failover. The connection or connection table is not replicated versus stateful failover. The connection table is replicated, allowing existing connections to continue. Okay. So if I was doing, what do you call it? Stateful or stateless. This guy goes down. He does not have, you know, when the traffic went out, the traffic went out from here, right? Good. The traffic went from here. The return connections, the inspection was done over here. Although I use this failover LAN interface for what? Config replication. I didn't say it was used for what? Connection replication. This guy does not have any connections at this point. So if this goes out, you'll definitely lose the connection. You'll lose the entire connection, Prashant. So he would need to reestablish. It's not even a packet loss, it's a complete loss. Downtime, yeah, about a minute. Generally, within a minute, you would have failed over. Less than a minute, I would say sub-minute. But yes, there is a connection loss, so you would have to redo it. Here, in the second one, stateful failover, although there is packet loss, but at the same time, the connections are replicated. To replicate the connection, you can either use a separate link or you can use a LAN interface itself, but you need to configure what is called link, failover link. The failover link is where you replicate what? Connections. Now you can share the same interface that I'm using for the LAN interface for failover link for connection replication as well. Doesn't have to be the same. You can have two different interfaces if you want. Entirely up to you. But again, what's going to happen in this case is whenever a connection is made this way, the connection will be seen over here as well. Connection, Xlate, both. Because if you don't do the Xlate on the other side, you'll have an issue anyways. So you need to do both, connection and Xlate. Will be replicated across over the failover link. Okay, so that's the other thing that I want you guys to be aware of. There is failover LAN interface used for config replication, required, and heartbeat, the keep alive. Failover link interface used for connection replication, could be the same interface as the failover LAN interface. So I can use the same interface designated as the failover LAN interface and the link. It is dedicated for that particular purpose. Understand the terminologies? So let's set this up over here. I do have a topology for this one as well. I'll bring it up, stand by, and I'll show you the diagram for it as well. So let's go back over here. This active standby, yeah. Save as. Ooh, I didn't get the other one. Yeah, I need to save this first. Five. And I can close it. And 6. All right, let's take a look at the physical topology. You have ASA over here. LAN interface connecting the two to each other. What I've done, I've used a separate link for the link. I could use the same. So I'll show you using both by itself or a different one. I have an outside network connected to the outside switch where I have router 3 connected. I have an inside network where I have router 4 connected, a separate switch. You have the same switch, you can also segregate it based on VLANs. But the critical part over here that you need to be very careful about, I need to connect the E00 of the two firewalls into the same switch. E1 of the two firewalls in the same switch. You cannot flip, because whatever configuration that I do on E00 is going to be done on the active box and on the standby box. So the same interface on the same side. So let me color it differently over here. So I have the red on the outside, and my inside will be like that. Okay. Guys, okay with this? So let's do this over here. And this is your logical topology, the way it's set up. So you'll have an inside network. Both E1s are connected to the inside. The IP address is 10.11.11.10 or 10.11.11.0 inside. R4 is on the inside. The active address will be 11. So whoever is the active device will get .11. Whoever is the standby guy gets .12 for him. From R4's perspective, the default gateway will be pointing to .11. So if this guy is the active, he has 11. He goes down, he takes over 11. And the same thing on the outside. I'm going to use the active address is 11, standby address is 12. Even on the failover interfaces, I'll have that. Initially, what I'm going to do over here is I'm just going to set it up based on what? Based on the single interface. I'm not going to do the failover link because I want you guys to see the stateless first. So this is my topology. Let me bring them up. Show IP interface brief. This is my outside device, 192.1.10.3. Show run line. Your telnet is set up, so I can test that as well. Okay. Show IP route. Zoom into what? Not a diagram. Which one? You mean change the font, maybe? Becomes too big then. Can everyone else see it or no? I think there's something wrong on your side. All right. So I have a default gateway pointing to .11, which is again the active address on the firewalls. Router 4, which is on the inside, pre-configured. 10.11.11.4, it should have a default gateway pointing to .11 as well. Okie doke. So this part is done. Now I'm going to go ahead and configure my ASA. This is a blank firewall, nothing on it. So what do I need to do to set up my failover? I do what is known as the failover bootstrap. Configuration. What do I do in this one? ASA 1, first thing I do is I bring up the interface that's going to act as my failover interface. Which interface in here is my failover interface? First thing I'm going to do before I do any of the config, set these two guys up. Which interface is it? That is the failover interface, the LAN interface, E2. So bring it up. This config needs to be done on both sides. Designate it as the failover interface for the config replication. Failover LAN interface, this guy. Give it a name. Let's say failover control FC, just a name. And which interface am I using? E2. So this is the name of the interface. This is the physical ID. You get my point? You don't go under the interface and say interface E2 name if, you do it using the failover LAN interface command. Now, once I'm done with that, I need to give it an IP address. So the command for that is interface IP to FC, which is the name of the interface. let's say 10.100.100.1, 255, 255, 2550. The thing is, you're not assigning this address to a specific interface. I'm assigning this address to the active address, wherever the active box is, will take on this address. Initially, when the election is taking place, the device that is designated with the higher priority takes this address by default. And the second one is a standby. So not only do I configure the active, but also the standby address over here, 10.100.100.2. Understood? So I'm assigning both the active and the standby over here. Which one do I take? That depends on my role. So I'm not assigning this to ASA1 actually at this point. But then I'll say failover LAN unit primary. What does that mean? My priority is primary. So if there's no ASA already elected as the active one, I will take on that 10.100.101. The other guy will take on 10.100.102. If there is no active box. Optionally, you can specify what is known as a failover key to validate your connection. And then you turn on failover by using the failover command. So this command by itself is a command that you turn on failover with. But before you do that, set all these other parameters in. You guys understand the parameters? This is doing what? Interface E2 nameif FC. Okay, this is assigning FC and IP address to the active box as 10.100.101. The standby box says 10.100.102. You don't need to put the default, the subnet mask over here, because this is should be on the same network. So this is a common subnet mask for both of them. I'm the primary unit. This is a key, not required. One at a time. Right now, I'm just doing the active standby stateless. I don't need the failover link. That's for need. That's for what do you call it? The connection replication. If I don't do it, my failover will still be up, but it'll be stateless. So this is your bootstrap command on the first box. Let's go to ASA1. It's blank right now. I'll paste my initial config. E2. Oh, it's a gig. So clear all the configuration. So gig 02. Let's paste it now. Looks good. So this is my LAN interface. What do I do on the second box? Identical configuration with one exception. A LAN unit on the second box will be secondary. That's the priority on the other one. And when I do this, these two guys will talk to each other over what? Over the gig 0 interface, do an election, and I will become the standby unit. You can check the status by doing show failover. It'll tell me that this host is the secondary, and my status secondary is what? His priority, but the main thing is his status. His status is what? Standby ready. Good so far? The other host is primary, but more importantly, it's the active box. Understood? If I go to ASA1, This host is active and the other host is standby. Clear so far? You'll also notice that the stateful failover link is unconfigured. That's okay. That means my connection replication will not take place, but at the same time, I'll still be working okay. Understood, guys? Now, from this point on, all the configuration will only be done on what device? What did I tell you? All the configuration is done on the active, not primary, active. Because if this fails, he's still the secondary, but he's active. You get my point? So even in that case, even if he's a primary standby, where's the config done at? Done on the active box. Primary, secondary does not have that big of an impact. It's the active standby that does. So from this point on, I do the normal config with one subtle difference. Normal ASA configuration with the difference of when you configure an interface, let's say I configure gig 0/0, my outside interface. When I go to set the IP address as, let's say 10 dot, is it 10 dot? Yeah, 10.11 as my address. I need to set up the active address. This is the active address and the standby address. Based on the role, the standby will take the standby IP, the active will take the IP, the active IP. I don't do any of the configuration on the other side. It'll automatically replicate that to the standby unit, and because it's a standby unit, it's going to assign itself this IP. So both IPs are configured on the active box. No shut. Done? You guys understand that? So you do need to specify an extra address for the roles. But all the config is only done on one box. I'm not done. I'll do a route outside 00. I believe it's 10.3 on the outside. Let's do NAT. You guys get the gist, right? Whatever I'm doing, I'm just doing it on one side, not on both. This configuration will be replicated to both sides. What is this? Dynamic Boole. So I'm on the active right now. Paste it. As soon as I paste it, immediately you will get that same config over here. But at the same time, if you check your IP addresses over here, show IP address is the command, you will notice that although the system addresses, system means the active addresses, are 11, 11, and 1, my current IPs are what? 12, 12, and 2. What does that indicate to you guys? I am not the active box because the active addresses don't match my addresses. I've taken on all the standby addresses. All right, but if I go to where? The active box, and I do the same command. What is it? 11, 11, 1, 11, 11, 1. So what does that tell you? I am the active box. I'm taking on the active addresses. So if I go to the inside device, which is this guy, and I try to telnet into 10.3, I should go out, it should get translated to 10.191. If I go to the ASA and I do show con, I have the connection. If I go to the ASA2, I don't have a connection. So one goes out, guess what? Yes, I will get redundancy within 15 to 20 seconds. The other one will pick it up. The hold down time is that much. But at the same time, the end user will have to redo the connection. Understood, guys? All right, good. So that's the case. Now let's do, this was what? This is active standby. Stateless. Let's do stateful. What is stateful? That link configuration that I talked about. I go over here right now, show failover. You'll notice that it says stateful failover. Link is unconfigured. How do I configure the link? Using a command called failover link. This command tells the ASA that you want to replicate what? The connection information over this link. Now I have two options over here. Number one, I can either use the same interface as my stateful replication link. How do I do that? Failover. The command is link. The interface, use the same interface name, FC, pointed to the same interface, gig0/2. And I'm done. Because this interface already has what? An IP address assigned to it. What was the IP address assigned to it? 10.100.100.1 and 2. Do you guys remember that? So if I use the existing link for the state and config replication, this is all I got to do. But let's say I want to dedicate a separate link for what? For stateful replication. The first thing I need to do, because the interface would be down, I need to bring it up. So let's say I'm dedicating gig0/3 for my state replication. So bring it up. Then I'll issue the command. My failover link is what? Let's call it SF for stateful gig03. So I'm designating the name as what? SF for gig03. But then it does not have an IP address. This one did because I had already done the no shot because it was also being used as my LAN interface. So I now need to give it an IP address, failover interface IP for SF. Let's say it's 10.200.200.1 subnet and standby and all that. So I need to do more for that. But now I have a dedicated link that is just used for what? State replication. So you can use the same interface or you can use two different interfaces. Let's use one first. I'll use the same interface. So again, the config only needs to be done on the active box because whatever I do on the active, it gets replicated. So what I can do over here, I can say failover link is gig 0/2 and what did I call it? FC. What happened? Oops. What does it say? Failover link FC gig, yeah, gig 0/2. Sorry. Eventually it'll come. Now, as soon as I do that, if I do show failover over here, you'll notice that FC is already up. Okay. Now, if I go back on here and do the connection again on ASA1, you should see the connection table. And if I go to ASA2, oops, you'll see the connection table. So now the connection table is getting replicated. Okay. So I'll exit out over here. Now, this was using what? The same interface, correct? Same interface as the failover LAN interface. Failover link. The command is link that really does it. FC gig 0/2. Or what was the other thing? The other way I haven't shown you yet. Let's do this first. Let's go in and blow this away. So I'll say no failover link FC gig 0/2. It's gone. Now if I do this, link unconfigured again. So what's the other way to do it? The way I'm showing it to you in the diagram, using the failover link command on a separate interface. So how would I do that? First, bring the interface up. Gig 0/3, no shut. Once it's up, give it a name, failover link, SF gig 0/3. And then give it an IP address. Interface IP for SF, let's say 10.200.200.1, 255, the mask. Copy it. Zip the space. Let's try it now. Just make sure it is space sensitive, just so put no space between the two. No, it's a different interface, Dylan. That was FC is for what? The failover control, that's a failover LAN interface. This guy over here. Okay. And this is my SF. That's for my failover link. So that's the second interface. So again, it really doesn't matter how you do it. As long as you have both, it's good. So now my connection table will be on both places. Got it? So I showed you both ways of doing stateful and stateless. What commands to issue a failover? Meaning, for it to go to the other guy, let's say you want to do a planned maintenance window where you want to bring it down. So what Keith is talking about is, let's say everything is working properly, but I want to do an upgrade. Right now, he's the active device. This is a standby device. So let's say I want to do an iOS upgrade. What I can do is, because it's a standby device, I can do the upgrade on it without affecting anything because it's a standby. I've upgraded this. Now I want to upgrade the active box. How do I make this the active box so that I can take it down, do the upgrade, bring it back up? As I told you, there's no preemption in the election. So if you want this guy to become the active box so that you can do some maintenance work on it, the way you do that is by using a command called failover active. So I can go to the second box, which right now is what? This host is what? I don't care about secondary. More importantly, I am standby ready, right? So what I can do over here is failover active. So as soon as I do that, it switches to active. Now my role is secondary active. Okay. The other guy now I can decommission or do whatever I want to do with it, upgrade it, maybe had to do some maintenance, fan was bad or something to that effect, fix it. Once I fix it, I want this to be the active again, failover active. Got it, Keith? So that's how you do it. That's if you want to force the switch over. Oops. Use the failover active command to do a manual switch over from standby to active. You have to do it on the standby unit. Because when you say failover active, I'm making myself the active manually. This is done on the standby unit. Good so far.